Hello everyone, good to have you back. We did a couple of demos on Hyperledger Fabric using IBM Blockchain Cloud, but now we're going to look at how you could do it yourself in your own virtual machine instance or your own laptop, for instance. You can do it wherever you feel like. But I'm going to be using a Ubuntu VM. I had asked for a certain set of prerequisites to be installed in the previous lecture. So let's get started. So a couple of links for how you can build your own network. So we're going to start from that. I'm going to start from this link on building a network. But once we are done here, I would encourage you to try and install an application on top of the network that we're going to build. So for instance, I'll show you where the marbles chain code is, and you can go deploy that same chain code on the custom network that you've developed on your or you've built on your virtual machine. So let's get there. So let's start with the instructions on how to build your network. So this is the page that I had the pointer to. So first you have to start with installing some prerequisites. The prerequisites, there's a link to the prerequisites. You can go over that, install those that are needed for this exercise. And there are what I've done as apart from setting up the prerequisites just to save time in the video. What I've done is I've also gone ahead and cloned this step. So first you need to go clone a piece of code. These are the Fabric samples. So we're going to use that as the starting point. So go please clone this GitHub repository, and let's get to the Fabric samples folder. So just follow these steps here. What it'll do is it'll go and pick up a lot of Docker containers in the background. So it'll get the peer container, the order container, the CA container. So it'll get all of those Docker images, and it will have that set up in your VM. So for me, it took about 10 minutes for this to run, but for you, it depends on your network, right? So it might be plus or minus a few minutes. So apart from once you've done those steps, you got those Fabric samples, get the binaries as well. Actually, the Docker containers are going to be fetched in the binary. So this step here, you have to go fetch the binary. So this is the peer order binary. So this is where actually it'll take the 10 minutes. Sorry about that. So getting the cloning the GitHub itself is just the code. So that'll be fast. So these two steps are something you have to run. It probably will take you 10-12 minutes to do that, but I've already done that for my VM, so we're going to start with that. Okay, so let's go back to the network now. So what are we going to do? Let's get to this is the command line interface for my virtual machine. So I am in this Fabric samples / first network. So I've got, let me get back to the Fabric samples folder. So in this there are many folders here, but I'm going to use the first network, but there are other examples as well. So there's a basic network that will give you a different topology, and will give you certain other aspects of setting up a network. But let's start with this first network. Okay. So first of all, before I start, let me show that I have a clean state now. So I'm looking at all the Docker containers I have on the system. There are no Docker containers. So this is the code that I'm going to use to set up my network. I've already cloned that code, and I told you how to do that. Now as a next step, I'll first show you what is the network that we're going to build, right? So this network, we're going to configure this in a file called cryptoconfig.yaml. So this is a file in your folder. We're going to open that file. So let's look at what this network is. So it's basically a specification of the network itself as a YAML file. And we're going to be using this specification in some of the scripts that we have to set up a network. So what does this have? So this has who are the orderer organizations. So there's a name of the organization called orderer. And it has a domain, example.com. And it has some specs, right? And then there are peer organizations. So we're going to have one entry for each peer. So there's a name called org1, org1.example.com. And then there is, it says template count :2. What this says is there are going to be 2 peers belonging to organization 1. So there are 2 peers, so count :2 belonging to organization 1. The second one, there is going to be an organization 2, And here again we are going to have 2 peers connected to organization 2. So we are going to have 2 organizations each running 2 peers. So that's going to be our network here. Now it also has a user count. So how many users are going to be created for each organization? So that's also part of this specification, right? So we'll run through this example. I would encourage you to also follow along in your virtual machine or your development environment, whatever you're using. Follow along these steps. Let's set this up, but separately, please do feel free to play around with these configurations. So for instance, you can change the number of peers, the number of users. You can go play around with some of these things. You'll see how the network gets set up. Okay. So let's get back. So this is the configuration file for the network. So this needs to be filled out. There is a template here that you can use directly. That's what we'll use right now. So that's the configuration file. And before we start, I'll also show you what crypto configurations exist. So right now, there's nothing in the network, right? No containers, no organizations created. So there's this folder called channel artifacts, right? If you look at that, right now it is empty. It just has a .gitkeep file. So there's nothing right now in the channel artifacts. So there's no channel that's been created, nothing in the configuration for that channel. There is also another directory that will get created here called crypto config, which will contain all the crypto material for your network. Basically the orderer certificates, the MSPs, the peers, the CAs, all of those, the crypto material for all of those will be in that folder. It will get created as we proceed. So I'll show you how that gets created and when it gets created. Okay. So that's just to show the clean slate from which we are starting. So there is a do it all script, right? So there's a script called build your first network, byfn.sh. So let's look at what that script really does, right? So this is the script that we're going to open. Okay. So let's look at some of the functions that it does, right? So this first print help just gives you how to use this. It has many functions. This generate function is going to generate some of the crypto material needed to set up the network. The byfn.sh up command is going to bring up the network. So it's going to create all the Docker containers for the peers, the orderers, the CA is going to bring that up. And it's going to create a channel called my channel, right? We can change that too. It's with the -c parameter. You can bring down the network also, byfn.sh down, and it's possible to upgrade the network from one Fabric version to another Fabric version. So these are the commands that are available, and certain set of optional parameters like the channel name, timeout, delay, what is the Docker compose file, and so on, right? So if nothing is specified, just default values will be used. Otherwise, you can specify what parameters to use here. So let's look at a few of these interesting functions that show what happens, right? So let's go to one of them, right? Let's first go to a thing called generate. Let me just jump to that thing. You can run through this file later, but I'm going to use. Okay, so this is file called generate certs. So this function called generate certs, what it's going to do is it's going to generate a certificate for a particular component or a user, right? So whether it's peer certificates, client certificates, or user or order certificates, generate certs is going to do that. And there is a CryptoGen tool that I've talked about in one of the lectures. So this is a tool that's provided with Fabric. It's a convenience tool for you to generate some of these certificates, these X509 certificates for you, right? You can also do this without CryptoGen using a Fabric CA, to generate these certificates. But in this example, we're going to use this CryptoGen tool. Okay. Generate channel artifacts. By the way, there are a lot of extensive comments here that you see. It all explains what's happening in each function, how it happens step by step. The generate channel artifacts is going to generate basically the genesis block and the channel configuration. Right. So maybe we'll come back to explaining that step, and then there is a function called network up. Okay, so this is that function. So this is the function, that's the main function that's going to bring up the network. Once all the crypto material have been generated, all the identities have been created for the peer, orderer, client, and so on. The network up function is going to bring up all the Docker containers running all of these entities. So by the way, we're going to have just one VM right now running all of these components. But eventually, think about the way blockchain would actually be set up is maybe each organization would probably run their own server running those components. It may even be a distributed system, like the peer may be on a different server from the certificate authority and so on, right? So eventually this will be a completely distributed system, but just for demonstration purposes, making it easy, we're just going to do it as Docker containers within a single VM. There are also instructions on how you can set up a multi-VM environment for, like, think of it as multiple VMs for each organization. That is also possible. There are instructions for that, and I would encourage you to look at that later. There are links from some of the pointers that I've given myself. Okay, so this network up function is the one that's going to bring up it's going to call Docker Compose. So there is Docker Compose file has all the components, and it has pointers to the Docker images to be brought up, right? So based on what you've configured, you will be bringing up that many peers, orderers, and so on. So that's what is happening in the network up function. Okay. So let's head back out of this thing. There are many other functions that you can look at, but let's head back. I will go back to the HTML file, gives you the overview of how to build your network. So going back to some of these things, right? So what are some of the things we are doing? We're going to be generating certificates first. Then we're going to generate the network artifacts, the channel aspects, where we're going to create the orderer genesis block, and then the channel configuration, and then we're going to add peers to that channel. So this is what we're going to be doing. So let's do that. So let me clear. Now the first thing I'm going to do is generate the identities for the different components. So this is using the generate function, generate command. So I'm going to run that. It will ask you for a prompt, yes or no. You can hit yes, and it has now generated all the identities. So let's go over what it has done. So we've used a CryptoGen tool, right? It has created an orderer genesis block. It has created a channel configuration transaction called channel.tx, and this is now initialized. The channel is now created, and then there are two anchor pairs, one for each organization. So org1 MSP and org2 MSP both have one anchor pair which has been added to the channel. And the way it's structured is only the anchor pair is going to be talking to the ordering service. The second pair in each organization will just talk to the first pair and obtain that information. And that is okay because it's both of those pairs are within the same trust boundary of the organization. So the second pair can trust the first pair, but each pair in the two organizations will not trust each other. They will both independently get the blocks from the orderer and will verify the orderer signature. Right, so all the identities are set up, the channel is set up, the peers have been set up. So that's what has happened so far. So while we edit, so the other thing to notice here is now the crypto config folder has been created. So this is where all the identities are currently stored right now. And again, a word of caution. Right now we've stored all these identities on file system. It might not be the best idea to do this. It's probably a good idea to put this inside, let's say, a hardware security module. If you're running this in production, you should really be storing these identities inside a crypto module in hardware so that it doesn't get stolen. Right? You could also do it in software, put it encrypted in a database. So all those are options. But for now, for the simple example, just to make things easier for you to get started as a developer, we just put it on the file system. Okay, let's look at the crypto config folder. So it has orderer organizations and it has peer organizations. So just to give you a feel for what this looks like, let's just go look at the folder structure. Within the orderer organization, example.com is the orderer that you created. And within that, it has the CA, MSP, orderers, the TLS certificates, and users. So it has folders for each of these. So you could go inside, let's say, let's go into orderers. It has orderer.example.com, and it will show you that MSP and the TLS certificates for the orderer. Right? So likewise, let's go back a few steps. You can go to peer organizations, and you will see there is org1.example.com and org2.example.com. Let's go into one of them. So org1.example.com again has the same folders, right? Same folder structure. The CA, MSP, peers, instead of the orderers, you now have the peers folder. And then again the TLS certificates for network communication and the users for that organization. So if you go into peers, go into peers, for this peer, we are going to, for this organization, we are creating two peers, peer0.org1.example.com and peer1.org1.example.com. So again, if you go into one of the peers, let's go into the MSP of that peer. This has, for instance, now the sign certificates. So this will be where the private key for the peer is. So sign certs is there. So this, if you see, is the private key that the peer will use to sign this, sign whatever messages it's sending out in the network. So maybe we can also open and view what this looks like. So this is the certificate that it's using to sign, right? You can also see some of the other things. For instance, you can go TLS certs and CA certs. So if you go to CA certs, this has the org1's CA's certificate, right? So all of these certificates have been generated and have been stored inside the crypto config folder. So okay, let's head back, right? So I've shown you where the certificates reside now. I'll do a Docker PS again now. There are no containers up at this point. We've only created the identities. We've created the Genesis block, but there is nothing else. So Genesis block is just the data structure, right? Nothing else. Okay, so next up, let's bring up the network. So what we're going to bring up is two peers, one orderer, two CAs for each of the organizations, and okay, that's what we're going to bring up now. So let's do that. So we're going to do byfn.sh up. So this command is going to bring up the network. It's going to do a bunch of things. Again, a prompt, press yes. Okay, so now this is going to create all of these entities. So the peer0.org1, peer0.org2. Okay, let's let it complete and then we'll go over the output. So it's going to run through a few things, and I'll walk you through what it's actually doing in the backend. And actually, you can go back to the code and also figure out each of these steps and what it's doing in the backend. So, okay, so while it's running, maybe you can just, it's going to take a couple of minutes. We'll start going through what it does, right? So first it created the channel. So using the channel configuration and the Genesis block, it went ahead and created this channel called my channel. It created that successfully. So it's out here. Then we're going to add the peers to the channel. So peer0.org1 has joined the channel, my channel. Peer1.org1 joined the channel. Then peer0 of org2, I think it's just skipped. Let's go back a bit. Peer0 of org2 and peer1 of org2 both joined the channel. Okay. Then anchor peers for org1 MSP or org2 MSP are updated. So we say that org1, so the peer0 is going to be the anchor peer. So we set the anchor peers for both the organizations, org2 and org1. So anchor peers are set. These are the peers that are going to be communicating with the orderer. Then we went ahead and installed a chain code. So this part I didn't tell you about. So I kept you in the dark about what it's going to do. There is a chain code that we've picked up and installed. So next up, we'll go look at what chain code we used. Right? So there's a chain code we set up on this channel. We installed that chain code on peer1, peer1.org2, and it's instantiated on the channel, my channel. Right? So let's go back in the output. So chain code is installed on peer0 org1. Chain code is installed on peer0 org2. So these are two anchor peers. We installed it on them. Then after that, it's rolled over a bit. Okay, its script is finished now, so that makes it easier for us to go over things. Okay, so the chain code has been added. So then the chain code was instantiated on the channel my channel, right, using peer0, which has already joined the channel. So once the chain code is all set up, then you can query and invoke the chain code. You can perform different transactions. So we'll do that. But before that, let's first look at what containers have started. So I'm going to do docker ps. So these are the containers that have started. So we have peer0.org1, we have peer0.org2, peer1.org1, and peer1.org2. So these are the 4 peers, 2 peers for each organization. We have one order that has come up. And note that we have not brought up a CA in this example. We used the CryptoGen tool to generate the certificates. We did not use a Fabric CA. So that's also the power of an MSP. We don't really, the Fabric itself does not care where these certificates come from, as long as the MSP knows the certificates, right? It knows the public keys for verification. So you can pre-generate the certificates, bring them on board into Fabric and plug them in, and that's what we're doing now. The other option, of course, is to have a Fabric CA, generate the certificates and give it to the network. Okay, so apart from that, there is chain codes that have been deployed. So chain codes have been deployed on org1, org2, and actually 2 peers on org2, right? So that's on both peer0 and peer1, chain codes have been deployed, and they have brought, those containers are up. And another cool feature of Fabric is that it automatically handles the fault tolerance of these chain codes. Let's say these are all Docker containers, right? The chain code might crash. What if this Docker container, this process crashes? The next time you perform a query or a transaction on that node, the chain code will automatically come up and then the transaction will run. So Fabric takes care of bringing up the chain code whenever necessary. Right, and all you have to do is when you instantiate, you're bringing up the chain code on that node. Only if you do a transaction or a query on another peer will that thing come up. So the reason we got these 3 up was because we performed transactions as part of the script. You will see that there were queries and there were queries performed on those peers, and when you perform those queries, those chain codes came up automatically. Okay. So I've been talking about chain codes. Let's go see what that chain code is. We actually deployed a very simple chain code. We'll go up one directory, we'll go to the parent directory Fabric samples. There's a folder called chain code, right? So this actually has multiple chain code examples, but the one we have used now is chain code example 02, right? I'll walk through the chain code example 02 for you. And note that there's also Marbles chain code. So this is precisely the chain code that we used and deployed in the IBM cloud, right, in the Marbles example. So this chain code is also available here. You can use this and deploy the Marbles chain code also on top of this network. So I won't be showing that to you, but I encourage you to do that as an exercise. Take this Marbles chain code, install it on multiple peers, instantiate it on the my channel that you've created. Right? So try that out as an exercise. Okay. So now let's look at chain code example 02. If you go in, there is a Go code as well as the Node code, Node.js code, which is the application code. But let's now only focus on the smart contract or the Golang code. So there is a chain code example 02.go. So let's look at this function. Okay. As would any smart contract, any chain code look, there are 2 main functions. One is the init function and the other is the invoke function. Right? The init is going to be called, as I mentioned, when the chain code is instantiated. So this is the first time some transaction is happening on this chain code. It's been instantiated. We will call the init function to initialize any state information. So what this chain code does, it's a very simple chain code. it has two state information. It has two accounts, account A and account B. They're both initialized with a certain balance. So you can think of them as bank accounts and they have a certain balance. So in this case, there is some error checking that's first done. We are first going to initialize A with a certain balance and B with a certain balance. And the balance is really an argument provided to the initialization function, to the init function. Right? So in this example, we are actually going to set A's balance to be 100 and B's balance to be 200. Okay. So this is what is going to get initialized as the state information for this chain code. And what is the function it supports? It supports invoke, delete and query. So this is the invoke function. It supports arguments for invoke, delete and query. So what I can do is I can invoke. What does invoke do? It actually makes a payment of X units from account A to account B. So it's going to decrement A's balance by X and it's going to increment B's balance by X. So that invoke function is out here. Right? Here here we are going to take those parameters, convert from string to integer. Fabric always takes all arguments as strings and you'll have to then morph them into any data type of your choice. Right? So here is the logic where A's balance is decremented by X, B's balance is incremented by X. But first, before doing that, you'll have to read the current state of the balance of these accounts. So that's done in this get state function. So the get state will read A's balance, get state of A reads A's balance from the ledger, get state of B reads B's balance from the ledger. They are both updated and then we have to write them back into the ledger. So we're going to do a put state of A saying this is the new balance for A, and likewise for B. We're going to do a put state for B. Right? So that's really what this chain code is about. Right? Separately, there is also a query function where you can just ask for the account balance. What's the account balance for A, or what's the account balance for B? It will return the balance. It will query the ledger. This is the get state function, and it will return that to the user. Okay, so that's all this chain code is about. Just account balances, and it allows you to transfer X units from one account to another. Okay, so let's head back and let's go back to the first network that we had. I'll again show you the containers. One other container that we skipped over is the CLI container. This is the command line interface that you can use to connect to the network. Right? So what I'm going to do is I'm going to now enter this container and create and run command line invocations and queries on the smart contract that we have deployed. So I'm going to use a cheat sheet here where I have these readily available. So what I'm going to do is I have just entered, I've used a docker exec command and I've now entered the container, the CLI container that I have here. So this is really the CLI container and I am in the peer folder inside the container. And from here, from this CLI container, this is really, think of this as the client, right? I'm now going to query and invoke the chain code. And note that as part of the initial script itself, there were a few transactions that happened. So there was actually one transaction that moved 10 units from A to B. So A's balance was initially 100, B's balance was 200. We transferred 10 units from A to B as part of this thing. So let's first start with querying the network. I have a CLI command here, so I'm going to use that. So let's just look at the structure of this CLI command. So it says peer chain code query. It has a reference to the channel, so -c my channel, so that's the channel we're going to operate on. MyCC is the chain code I've deployed, so I've installed on the channel, so it's -n myCC, and -c has the args provided. So the args are, I'm going to call the query function and I'm going to query for the account balance of A, right? So that's what this CLI command is going to do. So if you run it, you'll see the query result is 90 as expected. So this is the balance for A. Likewise, let's also query for the balance of B, and it says the balance for B is 210. Okay. So now let's do a blockchain transaction And again, I have a cheat sheet with full command so that I don't have to type that all out right now. Let's go over the structure of this invoke command. So it says peer chain code invoke minus o orderer. So you need to know who the orderer is. Minus minus TLS, saying I'm going to use TLS certificate, so all my network communication is going to be encrypted. TLS is true. What's the CA file? The CA is here. It has the full path to this TLA cert, the TLS cert for the CA. Minus C for my channel. Minus N myCC, this is the chain code reference. And minus C arguments. So in the arguments, we're calling the invoke function. We're going to say transfer from A to B so many units. So we're going to say in this order says 10 units, but let's say we transfer 40 units from A to B. Okay. So what we do is this is going to be an asynchronous transaction. So we've submitted this transaction onto the blockchain network, and blockchain has told us that yes, this has been accepted. We get a 200 back, but this is not yet committed onto the ledger. Right? It might fail for some reason, because maybe the account balances are not there, maybe someone else tried to also spend at the same time, so there's a conflict and the state is not, state validation fails. So there are many reasons why it could fail, but in this case I hope it's going to succeed. So let's query now for the account balance for A. You see that it's now deducted by 40. We transferred 40 from A to B, so from 90 it came down to 50, and we can see that B has gone from 210 to 250. So that's the atomicity. So either both accounts will be updated or neither will be updated. So if it fails, then the account balances will remain what it was before. It would have remained 90 to 10 if this transaction had failed. Right? So we've gone through how you set up a network by yourself from scratch. You created the identities, you created the certificates, you brought up the network as Docker containers. So in this network, we have one orderer, 2 peers for 2 organizations, so 4 peers total. And we instantiated a chain code. We performed certain transactions on that chain code. We also performed some queries to find out account balances. And so that's one simple application deployed on your own blockchain network. So as an exercise, as I mentioned, please do try and install the Marbles application and try and execute some transactions on that Marbles application. Okay, so with that, let's get back here. Apart from this, IBM has also put out many code patterns, example applications. Again, the code is there, the examples are there, so you can go quickly try those out as well. So there are many different code patterns provided. They're there in this link here. Okay, you can go look that up in the code patterns. So with that, I hope you have a good feel for how to get started using Hyperledger Fabric, develop your own applications, set up your network, deploy the applications there, and hopefully you can get started in building your own blockchain applications and do some projects. Thanks a lot. With that, we end this demo session. We'll see you at the next lecture. Bye.